Hello everyone, we're back with lab 5. In this lab, we are enabling communication between VLANs using inter-VLAN routing. Up to this point, our VLANs exist, trunking works, but devices in different VLANs were not able to communicate because switches operate at layer 2, and VLANs create a separate broadcast domain. And to move traffic between different broadcast domains, we need a layer 3 device. We have, which is our router in our case. We're using a design called router on stick. Instead of connecting multiple physical router interfaces for each VLAN, we create a logical subinterface on a single router port, and each interface represents a VLAN and acts as its default gateway. Now let's go ahead and get started with our here we have one router. So what we will, instead of connecting another connection from here for VLAN 10, for VLAN 20 and 30 and 99, we will make only this connection we will use this physical connection, this one physical connections, to create logical subinterfaces so that the traffic can move through this one interface. As always, we have the instruction here. And the first thing we are asked to do is to configure router subinterfaces. We do that on router 1. We press enter. We'll the interface is gigabit 0, 0. To create subinterface, we interface into the subinterface. And before we do that, let's see the difference. If we interface into gigabit G0/0, it says config if. Let's exit from here. And when we create a subinterface, we just add dot whatever the VLAN number is. In our case, it is 10. We will start with 10. And once we are in, the next is we have to use the command encapsulate .1q command to tell the router to tag traffic for VLAN 10. And the command is encapsulate .1q. Then we have to tell it which VLAN. I have to specify the VLAN number without writing VLAN. We just to show you what options we have, commands, we could do the set the ARP type. We can set the bandwidth information parameters, the delay description, encapsulation. That is what we used for our case. Exit is exit, IP, IPv6. This is IP is for version 4, IPv6 for version 6. MTU, no, shutdown, standby. These are what we have The next is once we set the encapsulation .1q to 10, we have to set the VLAN IP address for which will serve as the default gateway. And the way to do that is IP-addr 10.0.10.1 255.255.255.0. We exit from here. Then interface G0/0 .20. Uh, 1Q or 20. IP-addr is 10.0.20.1 255.255.255.0. Exit G0 int G0.0.30. Encapsulation .1q, which this time is 30. IP-addr would be 10.0.30.1 255.255.255.0. Now we have set the default IP address for each VLAN. We have created the sub interfaces. The next is interface V0/0. Then from here, we say no shut. This will bring up all the connections, including the sub-interfaces. Now that we have done this, the next step is we have done step 1, 2, and 3. The next is step 4, and that is on switch 1. And we have to turn this connection into a trunk port. Otherwise, the different VLANs wouldn't be able to be trafficked over this connection. Enable the interface FA0/1, and to turn it into to make this into a trunk port, switch port mode trunk. Switch trunk the trunk allowed VLAN would be 10, 20, 30, and 99. Then no shut. Then we'll bring this up. We'll bring this interface up. Even though it is not included in here, what we could do is we can also create default gateway for VLAN 99, even though we don't have anything connected to it. But we will leave it for now. If we try to reach out to ping to VLAN 99, it wouldn't work. The next is to assign the default gateway on the PCs and update PC setting. And we start, this is PC1, and the default gateway is 10.0.10.1 because this is a VLAN 10 PC. PC2 is 10.0.20.1 because this is a 20. PC3 is 10, VLAN 10, so the 10.0.10.1. And PC4 is a .30, so 10.0.30.10. Now we can test connectivity, verify everything works by doing a ping. Ping 10.0.10.10. We expect the first one to fail, but the others should work, the other three. Check. Okay. Okay. VLAN 10. Why is it not working? Okay, let's check. Oh, it's because the default gateway is wrong. It's not 10, it is 30.1. Now let's try again. The first one will fail, but the others should work. Okay. Yep, as expected. You know, this kind of mistakes are expected will happen in the job, and it is always good to know how to troubleshoot. The 20 VLAN is this one. So PC4 is able to reach PC1 through 3. PC1 should be able to reach 10.0.30.10. Ping. Now it's faster because they already know each other's address. 20. Good. PC3. Reaching PC3 should be easy. So now we have confirmed that we have connection between PC1 and the other PCs. Let's try on this one. Ping 10.0.30.10. Ping 10.0.20.10. Oh, that's pinging itself. Yeah, because it's PC2. Ping 10.0.n.10. Yep. .11. So we have confirmed that we have connection between all the PCs that are connected. So it is important to understand that the subinterfaces are not physical interfaces; they're logical gateways that that route traffic between VLANs. And once we have configured that, and we have to configure the other side of the switch as a trunk port. We have to always remember that, and we have to let the VLANs. We have to allow the VLANs that we want to be routed to the router on the trunk port. So we have allowed controlled communication between the different virtual networks. And in the next lab, we will move beyond the local network and configure static routing between routers.